All right, welcome back. Today we get to a much more complicated lesson with matrix multiplication. Um, in my opinion, this is the most important and most challenging, if you don't follow all the steps, thing to do in this chapter. So let's go and get started. So 4-2 is over matrix multiplication. And it is not something as simple as multiply all corresponding entries like you might think. There is a specific way that it is defined and done, and this specific way is convoluted to say the least. It's a it's a bit of a process. So 4.2 matrix multiplication. Now this warm up is going to be important for us. Write out an arbitrary 3 by 2 matrix called matrix A, where each entry in A is labeled correctly. So an arbitrary matrix is talking about a matrix in which the elements are not given specifically, but instead you've got the addresses for each element. So I'll get you started on this. It's a 3 by 2, which means there's going to be 3 rows and 2 columns. So there will be 3 rows and 2 columns. All right, following along so far? So that is what it means for it to be a 3 by 2 matrix. Now, it's called matrix A, so it's going to have A as a label, and then each entry is also going to have the label A. And then they'll also have their individual address here. So I'll get you started and then you try to do the rest of them. So the first row, first column entry will be A11. The second row, first column entry will be A21. Do you guys get the idea? If you can, try to pause the video and finish this by labeling each of these other A's with their address. Okay, so you should have gotten 3-1 because this is third row, first column. Here you should have gotten 1-2 because it is the first row, second column. This is the second row, second column, and this is the third row, second column. Third row, second column. All right? Your ability to do this is what's going to be the deciding factor in whether you can do matrix multiplication in a convenient way or whether it's going to be challenging for you. So I encourage you to practice this if you are not good at it. And just to give you something to practice, try to make a 4 by try to make a 2 by 4 arbitrary matrix. All right, if you don't have a good grasp on this, go ahead and try to give me an arbitrary 2 by 4 matrix in the same way where we'll call it matrix B. And if you do have a good grasp on this, then go ahead and skip past this while I wait. All right, so pause the video and try to make a 2 by 4 if you're not very good at this. All right, so hopefully you should have gotten that it had 2 rows, 1 row, 2 rows. I'll use a different color here. 2 rows and 4 columns. Okay, so if it was called matrix B, then the addresses are all going to have little b's. And then the entries, the specific ones, these elements, will be like 1, 1 for first row, first column. Then you can go over here to 1, 2. That's the first row, second column. Then you've got 1, 3. That is the first row, third column. And 1, 4. That is the first row, fourth column. Then here you've got all your second row stuff. This is second row, first column. Second row, second column. Second row, third column. Second row, fourth column. Okay? You following along? All right, hopefully that was some more practice for those of you who needed it. Now, just like addition and subtraction of matrices had to have compatible dimensions to add and subtract, Namely, they had to have the same dimensions. Their dimension, they had to have the same number of rows and the same number of columns, right? Um, when you're trying to multiply two matrices, they also have to have compatible dimensions, though they are not necessarily going to be the same dimensions. So here's how it works. And you should write this down. The columns of the first matrix must equal the rows of the second matrix. That's it. If the columns of the first matrix equal the rows of the second matrix, like the number of columns in the first matrix and the number of rows in the second matrix, then these can be multiplied. All right, so go ahead and write this down. All right, so let's dissect this. The number of columns in the first matrix. So remember, this is rows by columns. So the columns of the first matrix. So this is the first matrix here, if you're multiplying these together. So that is 3. Must equal the rows of the second matrix. So this is the rows and this is the columns. So that's to say that the columns of the first matrix must equal the rows of the second matrix. Do you guys see? So do these two numbers equal each other? And the answer is yes. So these two matrices, a 4 by 3 and a 3 by 5, can be multiplied together because the columns here match the rows here, okay? Now, let's look at the next examples. Can you multiply a 3 by 3 and a 3 by 2 together? The answer is yes. The columns of the first match the rows of the second. And a convenient way to see this is if you were to put the two matrices dimensions that you're trying to multiply, if you were to write those out, 3 by 3 and 3 by 2, if the inside numbers match, if these inside numbers match, you can multiply. And it gets there. This is even more useful because if you can multiply them, the answer to your multiplication problem, like when you do actually take the matrix and multiply it, the dimensions of that resultant matrix will be these outside numbers. The answer will be the outside numbers in dimension. So your dimensions would be a 3 by 2, a 3 by a 2 in this example. All right? So let's look at the last example. Can these two matrices be multiplied together? The answer is no. These inside numbers do not match. The columns of the first do not match the rows of the second. And so these cannot be multiplied. So the first one can be multiplied, the second one can be multiplied, but the third one cannot be. All right, so now that we know, now that we can label specific elements within a matrix like this, and we can determine if matrix multiplication is possible, and we now know what the resultant matrix dimensions will be, let's go ahead and define what matrix multiplication is. So that would be down here. All right, so go ahead and write this down. I'm going to take just a second here. Okay, so pause the video. I'm sure you'll need more time to write this down. Matrix multiplication is a sum of products. A sum of products. That's the key phrase of what we're doing. It is a sum of products. You take the rows of the first matrix times the columns of the second. So it's rows times columns. Now, this very helpful suggestion is my biggest piece of advice for students who are doing matrix multiplication. Write out the resultant matrix as an arbitrary matrix of the proper dimension. So, A is a 2 by 2, 2 rows, 2 columns. B is a 2 by 3, 2 rows, 3 columns. So if you check the inside numbers, they are the same, so you can multiply them. And the outside numbers are the dimensions of the answer, which would be a 2 by 3. So our matrix, which we will call C for no particular reason, is going to be a 2 by 3 matrix. And what we need to do is we need to write out an arbitrary 2 by 3 matrix where all the entries are like C11, C12, C13, that sort of thing. So this is what we had practice on at the beginning of this lesson. So all the entries are going to be C, and there are 2 rows and 3 columns. So if you look here, this should be done correctly. There are 2 rows and 3 columns. Okay, so there are 6 entries. Now, back to the naming. This is 1, 1. That is to say, it is the first row, first column entry. First row, first column. First row, second column. First row, third column. This is the second row, first column. Second row, second column. Second row, third column. Okay? So, the reason we want to do this is because these individual addresses help us immensely when it comes to figuring out how you get the answers here. And it's not as simple as take this number times this number, put it here. Take this number times this number, put it here. It is not that simple. So here's what we do. You guys remember, as we just did, that this is the first row, first column. First row, first column, right? So what you do is you take the first row of the first matrix and the first column of the second matrix and multiply them together. So it's first row, first column. So what that looks like is this. First row, first column. And what you do is you take the corresponding entries and multiply them together. So the first entry here and the first entry here, you multiply them together. So we'll do this in yellow. C11 is going to be equal to -2 times 3. And remember, we first defined this as a sum of products. So there's a product, and now you add it to the next 2 entries multiplied together. So 1 times -1. 1 and -1. And that would be, once you simplify this, your first row, first column entry. So that is to say -6 minus 1, which is -7. So C11 is 7. -7, excuse me. So that's how you get one of the entries. And I know this is a tedious, complicated process, but it does really hone your skills at, trying to avoid making basic arithmetic mistakes, and gives you practice at doing this sort of thing. Right? It's just good math practice. So here, the next one we have C12. So what you'll do is you'll take the first row because of this 1, so that means the first row, and the 2 indicates the second column, just as it did here in this address. First row, second column, that is what we'll take to get our answer. First row, second column. So we're reusing the first row. And what you end up with, C12, is the first entry and the first entry times each other. So -2 times 0. You add that with the second entry and the second entry multiplied together, which would be 1 times 4. And that gets you 0 plus 4, which is 4. And so this is a 4. This process continues where you use this scheme, this naming scheme here to figure out what you use. So this would be first row, third column. So let's go ahead and do first row, third column. Okay. And write that down. So that's going to be C13 equals the first entry times the first entry, which is -2 times 2, plus the second entry times the second entry, which is 1 times 0. And you get -4. So that is your next entry, 1, 3. Okay, so now we do C21, C22, and C23. So if you guys think you have a handle on this, then by all means stop the video and try. And if not, then go ahead and keep watching. At some point, though, you will need to do all these problems alone, like all the homework problems. So definitely best to get off the training wheels as soon as possible. So I'll do this next one in blue. C21 uses row 2, column 1. And that looks like this. Row 2, column 1. And so that's going to be, C21 is 3 times 3 plus 1 times -1. Or 0 times -1, excuse me. Sorry about that. 0 times -1. My hand covers up stuff. All right, and so that's going to give you 9. So this entry is 9. Then you've got C22, and that uses the second row, second column. Second row, second column. Okay, and that's going to be 3 times 0. So this is C22, and that is 3 times 0 plus 0 times 4, which is 0. And finally, our last entry, I don't think I have a color for it. I'll use white. Our last entry uses the second row and third column. So that is to say, this second row, third column. Okay. C3, excuse me, 2, 3. So that's going to be the second, the first entry here, 3 times 2, the first entry and the first entry. And that's going down, by the way, right, as the rest of these have been. So 3 times 2, and then 0 and 0. And you get 6. And so this entry is 6. So your overall answer would be -7, 4, -4, 9, 0, 6. That is your actual answer. I know it's a complicated process. I did warn you at the beginning of the lesson. All right, so now if you guys want, actually, if you want to help yourself out the most, try to work this 2 by 2 times 2 by 2 out. And we're going to call this matrix C because why not? So my advice to you is write out the resulting matrix. And to do that, you'll need to know the dimensions of the resultant matrix. And you find the dimensions of the resultant matrix by first seeing if the matrices are, if you can multiply them. So this is a 2 by 2, and this is a 2 by 2. So the inside numbers match, and the outside numbers are the result. The resultant matrix is dimensions. So you've got 2 by 2. So your resultant matrix is a 2 by 2. And it's going to have entries of C11, C12, C21, C22. The faster you can do this, the better. And then C11 is found by taking the first row times the first column. First row, first column. Okay. And multiplying and doing a sum of products. So that is 1 and -4 multiplied plus -3 and 2 multiplied. So you've got 1, -4 plus -3, 2. And that's going to get you -4 minus 6, which is -10. So that entry is -10. All right, next you have C12, and that is first row, second column. First row, second column. So that's going to be 1 times 0, which is 0, and -3 times 1, which is -3. So you get -3. Then you've got C21, and that's going to be the second row, first column, second row, first column, and that's 0 times -4, which is 0, and 4 times 2, which is 8. So you get 8. And finally, C22. And C22 is second row, second column. Second row, second column. And that is 0 times 0, which is 0, and 4 times 1, so plus 4. And there you have it. There's your answer. All right. Let's try to multiply this one here. And I think this is your last lesson. This is your last example. So you guys should try to do your best to do all of this alone and see if you get the right answer. I'm going to talk my way through it quickly as I work it out. If you are still needing help, pay close attention to what I'm saying because I'm going to be going pretty quickly. So let me take a drink first, then I'll get started. Okay, so first off, check for compatible dimensions. Make sure they can be multiplied. So this is a 3 by 2, and this is a 2 by 2. Check the inside numbers. They match. Check the outside numbers. All right, so our matrix, I will call our answer C. It's going to be a 3 by 2. And so a 3 by 2 would look like this, where there are 3 rows and 2 columns. I'm going to label them all. C11, C12, C21, C22, C31, C32. And that will help me find what these, this will help tell me how to get each of these answers. So C11 here is going to be first row, first column. So that would be 1 times 2, which is 2, plus 3 times 0, which is 0, and so this would be 2. Then you move on. I'm going to go to 2, 1. That's row 2, column 1. So -2 times 2 is -4, and 0 times 0 is 0. So you've got -4. Then C31, that's row 3, column 1. So that's -3 and +2. That's -6. And 1 and 0, that's 0. So -6. Then 1, 2, C12, that's row 1. Right, this is row 1, column 2 this time. 1, 2. And so you're going to get 1 and -2, that's -2 when you multiply, plus 3 times 1, which is 3, so that's a +1. Then you go 2, 2, so that's row 2, column 2. So -2 and -2 make a +4, and 0 and 1 make 0, so this is just +4. And then you've got 3, 2, so that's row 3, column 2. So row 3, column 2, that's -3 and -2, that's a +6. And then 1 and 1 is 1, so you add them together and you get 7. And there's your answer. All right, not so bad, hopefully, by the end of it. Here's your homework. It's on page 250, problem set 1, 2, 6, 7, 8, and 11. You guys know the homework now, and I'm sure you know the due date. Go ahead and work on this. This is the key part of this chapter in terms of what it is I'll be asking of you on a quiz or a test. Being able to check compatible dimensions and write out arbitrary matrices and multiply them together. And then inverses rely on you being able to multiply them together, and everything else will revolve around this sort of stuff. So your basic operations are covered: add, subtract, and multiply. Matrix division is not defined, so we don't have to worry about that. Right? If you you have any questions, let me know. How about it?